James Webb will go where no other telescope has gone before.
What lies right at the edge of what we can see in the universe has been a mystery captivating minds for centuries, sparking curiosity and debate among scientists and space enthusiasts alike. But now, thanks to the James Webb Space Telescope, we're on the brink of uncovering this cosmic enigma. With its powerful lenses peering deeper into space, this groundbreaking telescope has recently made a significant announcement about what lies at the very edge of what we can observe. To grasp what's at the edge of the universe, it's crucial to grasp the concept of the observable universe. Essentially, it encompasses everything within our sight, everything we can measure and study from Earth or our space-based instruments. Currently, it consists of stars, galaxies, and other cosmic objects within our observational range. Now, what's the difference between the universe, with a capital U, and the observable universe? Simply put, the observable universe is just a tiny fraction of the whole universe that we're able to explore and understand, while the complete size and nature of the entire universe remain a mystery. The estimated diameter of the observable universe is around 93 billion light-years. A light-year, for reference, is the distance light travels in a single year, roughly equivalent to 5.88 trillion miles or 9.46 trillion kilometers. So, envisioning the diameter of the observable universe at 93 billion light-years stretches across an unimaginably vast expanse spanning approximately 546,845,568. According to the Big Bang Theory, about 13.8 billion years ago, the universe burst into existence in an immense explosion. This cataclysmic event set off a rapid expansion, and since then, the universe has been stretching out at an ever-increasing rate, driven by mysterious forces like dark energy. As the universe expanded, particles of matter began to clump together under the influence of gravity, giving rise to awe-inspiring structures such as stars, galaxies, and eventually planets like our own Earth. Over eons, these cosmic structures continued to grow and evolve, leading to the breathtaking diversity of objects and phenomena that we observe throughout the cosmos today. Despite the seeming enormity of the universe, it's predominantly empty. To illustrate, if we shrunk down our entire solar system to the size of a quarter, the nearest star would still be as distant as 2 soccer fields away. And that's just within our Milky Way galaxy, which is just one among billions in the observable universe. Have you ever pondered why we can't catch a glimpse of the entire universe? Well, there are a couple of reasons behind this intriguing mystery. Firstly, light, the messenger of the cosmos, takes its sweet time traveling through the vast expanse of space. So, when we gaze at distant celestial objects, we're essentially peering into the past as we see them as they were eons ago. The farther away something is, the older the light we perceive. It's like taking a trip down memory lane, unraveling the cosmic history book. Secondly, there's the universe's ongoing expansion, a phenomenon akin to watching dots on an inflating balloon drift further apart. As space stretches, so does the distance between galaxies, causing their light to stretch too, shifting towards longer wavelengths, what we call redshift. Eventually, some of these far-flung objects slip beyond our reach, receding into the cosmic abyss. So, you see, between the cosmic speed limits of light and the universe's expansion, it's no wonder we haven't glimpsed its entirety yet. Now, let's dive into the perplexing concept of the universe's edge, a subject that has intrigued scholars and thinkers for eons. While we're still grappling with the enigma, 3 prominent theories have emerged to tantalize our imagination. First off, there's the notion that the universe stretches endlessly, with no boundary in sight. This idea stems from the cosmological principle, which suggests that the universe looks pretty much the same from every angle. If this holds true, it implies an infinite expanse that stretches beyond our comprehension. Then, there's the theory that the universe is finite but lacks a distinct edge. Picture it like a mammoth sphere. If you journey in any direction long enough, you'll loop back to where you started, like taking a stroll around a giant cosmic marble. And last, but not least, there's the multiverse theory, a mind-bending concept proposing that our universe is just one of countless others. Imagine a vast ensemble of parallel realities, each with its own unique quirks and rules. These universes might exist independently or somehow intersect with each other, forming a tapestry of cosmic diversity. So, while we're still scratching the surface of cosmic mysteries, these theories offer fascinating glimpses into the boundless wonders that lie beyond our cosmic doorstep. So, we've delved into the concepts at the edge of the universe, exploring various theories. Now, let's shift our focus to an incredible tool that could unravel these mysteries, the James Webb Space Telescope, JWST. This remarkable telescope allows us to peer far back in time, unveiling hidden treasures from the universe's infancy. With its cutting-edge technology, the JWST has provided astronomers with a glimpse into the universe's earliest epochs. And guess what? It's uncovered something unexpected. In a recent study published in the journal Nature, the JWST stumbled upon 6 colossal galaxies dating back to 500 million to 700 million years after the Big Bang. Astonishingly, these galaxies aren't the small fledgling ones scientists anticipated. They're massive, challenging our understanding of the early cosmos. What's more, they're remarkably mature, akin to our 13 billion-year-old Milky Way. The star mass within each of these behemoths totals several billion times that of our Sun, with one possibly reaching a staggering 100 billion solar masses. To put it in perspective, that's roughly 60 billion suns worth of stars in one galaxy, dwarfing our Milky Way. The JWST possesses a unique ability to detect infrared light, unveiling hidden phenomena invisible to our eyes. By capturing the faint glow of ancient stars and galaxies, it effectively transports us back in time, offering a glimpse of the universe's distant past. Now, here's the truly fascinating part. Given that the universe is roughly 13.7 billion years old, this discovery has thrown conventional wisdom into disarray. It's akin to rewriting the history books. These colossal galaxies, aptly dubbed universe breakers, have left scientists baffled. They defy nearly all the models we had for early galaxies. Previously, we believed galaxies began as small clusters of stars and dust, gradually growing over time. However, these universe breakers have shattered that notion. When researchers got their hands on the Webb data and saw the high-resolution images from the telescope in July 2022, they were completely amazed. The sight of these galaxies shining brightly caught them off guard, making them question their own interpretations of the data. It was as if these colossal objects had suddenly appeared out of nowhere, surprising everyone. By using spectroscopic techniques to analyze light at different wavelengths, scientists can uncover important details about these galaxies, like what they're made of, how big they are, and how far away they are from Earth. What's really fascinating is that this groundbreaking discovery wasn't even something scientists were expecting to find at the top of their list with the James Webb Telescope. It went beyond all expectations and happened much faster than anyone anticipated. There's even a chance that some of the objects spotted using Webb data might not be what they seem. While most of them are likely galaxies, there's a possibility that a few could actually be hidden supermassive black holes. Here's the really intriguing part. The known mass of stars in the universe is now believed to be up to 100 times greater than what we previously thought. And that's still an astonishing discovery, even if we only consider half of the data. Meanwhile, using the powerful James Webb Space Telescope, JWST, an international team of astronomers also made an amazing discovery. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to a time when the universe was just a fraction of its current age, less than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Similar to what the Hubble Space Telescope observed in its early days, the first images captured by the JWST revealed numerous potential galaxies. Now, through careful spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the physical properties of the galaxies, but also to accurately determine their distances. To figure out how far away a galaxy is, astronomers calculate its redshift. You might be wondering, what exactly is redshift? Well, it turns out that as the universe expands, objects seem to move away from us, which makes their light stretch and shift toward longer, redder wavelengths. This is what we call the Doppler effect. While estimates of redshift can be made from photos taken through different filters, spectroscopy is the preferred method for getting precise measurements, as it breaks down the object's light into its different wavelengths. The latest findings zoom in on 4 galaxies situated incredibly far away, with redshifts surpassing 10. In simpler terms, these galaxies are super distant. Previously, the Hubble Space Telescope had caught sight of 2 of these galaxies, confirming their redshifts to be 10.38 and 11.58. However, the JWST, James Webb Space Telescope images uncovered 2 galaxies even farther out, boasting redshifts of 13.20 and 12.63. A redshift of 13.2 indicates a time roughly 13.5 billion years ago, unveiling ancient cosmic history. Adding to this, there's the JWST Advanced Deep Extragalactic Survey, JADES, a bold initiative that has been granted over a month of the telescope's time. Its goal is to offer an unparalleled, detailed peek into the early universe. Back in 2015, a group of instrument teams proposed this project, forming an international collaboration known as JADES, consisting of over 80 astronomers and scientists from 10 different countries. To kick things off, the JADES program focused on a specific area of the sky, including the Hubble Ultra Deep Field, for more than 10 days using the NIRCam. For more than 2 decades, astronomers have been studying this region with various large telescopes. By examining the field across 9 different infrared wavelength bands, the JADES team stumbled upon an astonishing revelation: nearly 100,000 distant galaxies, each billions of light years away. Following this, using the NPX spectrograph, scientists gathered light from 2,150 faint galaxies over a 3-day observation period. This allowed them to unveil the properties of the gas and stars within these galaxies, obtaining precise redshift values. With these measurements, astronomers can gauge the inherent brightness of the galaxies and make estimates about the number of stars they harbor. This paves the way for a thorough exploration of galaxy formation across time. Even without direct insight into their early developmental stages, studying galaxies can be as perplexing as understanding human beings. The initial generations of stars leave a significant mark on the future of galaxies, akin to how our early life experiences shape our journey. We're witnessing an extraordinary era in history where the transformative capabilities of the Webb telescope are unraveling numerous mysteries about galaxies. NASA's Deep Space Observatory telescope is reshaping our comprehension of the cosmos, unveiling a trove of new discoveries. The James Webb Space Telescope, JWST, is blazing a trail in scientific exploration, unveiling stunning revelations about galaxies, planets, stars, and other captivating cosmic phenomena. Launched in December 2021 with a mission duration of 2 decades, Webb is just beginning its thrilling journey through the cosmos. Exceeding the achievements of its forerunner, the Hubble Space Telescope, Webb has captured the imaginations of scientists and the public alike, igniting a surge of scientific passion. People worldwide are eagerly delving into the telescope's raw data, sharing its awe-inspiring images, and gaining new perspectives on the universe. With a flawless deployment and remarkable initial images unveiled in mid-July, Webb has provided an unprecedented glimpse into the myriad facets of our universe. Its advanced infrared technology allows us to delve into the farthest reaches of galaxies with remarkable clarity, peering deep into the cosmic past. Since going online in late June 2022, Webb's powerful instruments have unveiled thousands of previously undiscovered galaxies, many older and more distant than ever imagined. Furthermore, the telescope's capabilities enable scientists to capture abundant light from celestial bodies like exoplanets and nascent stars, revealing their compositions and trajectories through space. This wealth of data is already unraveling intricate details about the atmospheres of planets situated hundreds of light years away, offering tantalizing hints about their potential to support life. Notably, Webb's analysis of faint light traces from the universe's early days has potentially identified the oldest black hole ever observed. This supermassive black hole, with a mass 9 million times that of the Sun, resides at the heart of a young galaxy formed just 570 million years after the universe's birth. The discovery, made possible by Webb's powerful cameras capable of peering back in time, sheds light on the cosmic dawn when numerous black holes began to grow in size following the Big Bang. The origins and proliferation of these mysterious cosmic entities continue to perplex astronomers, but Webb's groundbreaking observations are steadily unraveling these cosmic mysteries. Some of the largest cosmic events we know of produce light that we can see through telescopes. This light comes from the clash of material swirling into massive gravitational voids. These phenomena, referred to as active galactic nuclei, AGN, supermassive black holes or quasars, outweigh the Sun by billions of times and shine with bursts of light trillions of times brighter than even the most luminous stars. They represent the most extreme type of AGN. As scientists explore further into space, they're able to capture light from sources that are even farther away, offering glimpses into the universe's earlier days. The James Webb Space Telescope, JWST, plays a crucial role here, using its mid-infrared tool and near-infrared camera to scan the skies for black holes. It then breaks down the light into different frequencies using spectrographs, providing data for analysis. During their studies, scientists stumbled upon a significant finding. The heated material encircling a black hole emits faint traces of radiation across the cosmos. By closely examining these subtle glimmers from the universe's infancy, they noticed an unexpected surge in the frequencies embedded within the light, offering valuable insights into cosmic processes. The sudden appearance of black holes in our young universe remains a puzzle. Scientists are on the hunt for much younger primordial black holes, thought to have formed shortly after the Big Bang, or perhaps even earlier, though these elusive objects have yet to be found. There are two main theories to explain the abundance of black holes in the universe today. One suggests they are remnants of massive stars that formed much faster than contemporary stars. Alternatively, it's proposed that dense clouds of gas rapidly collapsed, forming these mysterious singularities in spacetime. A likelier scenario involves a population the 3 star, a theoretical type of star composed mainly of hydrogen and helium that emerged about 200 million years after the Big Bang. Such a star would have exploded, leaving behind a black hole. Scientists are working with the developers of MIRI to examine the light from a distant galaxy and gather more clues about the formation of the enigmatic black hole at its center. Additionally, researchers have looked into the early stages of the universe and observed the formation of a protocluster containing 7 interacting galaxies. This cluster, spotted by the Hubble Space Telescope, is the most distant galaxy cluster ever identified. Simulations indicate that it's on track to become one of the oldest and largest galaxy clusters ever known, boasting a mass nearly 100 times greater than our Milky Way. Initially spotted by the Hubble Space Telescope, it couldn't precisely gauge the distances between the galaxies due to its limited sensitivity. Imagine looking down from high above Los Angeles through a telescope. You might see Phoenix, Dallas, and Atlanta, but judging the exact distances between them would be tricky, right? However, thanks to the James Webb Telescope, we've gained a much clearer view. These kinds of clusters, scientists say, are extremely rare and hard to detect. While it's improbable that the JWST will stumble upon another unique system like this, the forthcoming Nancy Grace Roman Space Telescope, slated for launch in early 2027, will significantly boost our capacity to spot galaxy clusters in the early universe. Its wide-area survey capabilities will surpass the JWST's by over 100 times. Returning to the JWST's discoveries. In the 1990s, astronomers made groundbreaking finds regarding exoplanets. Thanks to this groundbreaking telescope, we've identified over 3,000 extrasolar planets. Although only a dozen have been directly imaged, most exoplanets are so distant that we can only detect them when they pass in front of their host stars, causing a slight dimming of light. However, the JWST has changed the game. With its coronagraphs, cameras, filters, and other equipment, scientists can now directly observe exoplanets. In 2017, the Sphere Consortium made a significant breakthrough by pinpointing a planet named HIP 65426b using the Spectrometric High Contrast Exoplanet Research Instrument. HIP 65426b orbits its host star HP 650426. It gained further attention in September 2022 as the first exoplanet directly observed by the James Webb Space Telescope. What sets this planet apart is its unique characteristics. Coupled with the remarkable sensitivity of the James Webb Telescope, which simplifies observation, HIP 65426b sits at a distance from its host star that is 100 times greater than the distance between our Sun and Earth. To put it into perspective, Pluto is only 40 times farther from the Sun than Earth. Picture a distant world, a colossal gas giant dwarfing even Jupiter in size. This exoplanet, hidden within the vastness of space, reveals itself in all its brilliance through the lens of Webb's infrared camera. Casting our gaze upon the phantom galaxy, elusive though it may be in the night sky, we're treated to a spectacle of cosmic wonder. M74, a galaxy of stunning beauty, unveils its spiral arms and scattered stars, its radiant core reaching outwards like welcoming arms. Hubble's optical lens captures this splendor, painting a vivid picture of swirling gas and dust in electric blue hues. Webb's infrared snapshot showcases the galaxy's star-forming regions, ablaze with celestial creation. By blending images from both Hubble and Webb, scientists have crafted a breathtaking mosaic, blending optical clarity with infrared insight. Featured in an international film project, these images offer astronomers a side-by-side comparison, aiding in the identification of stellar nurseries and the precise measurement of star clusters. Webb's observations extend beyond galaxies, delving into the mysteries of interstellar dust and distant stars. One such star, WR 140, displays a curious diffraction pattern surrounded by concentric rings that give it a distinct boxy appearance. These rings, far from being mere artifacts, are the result of the star's interactions with its surroundings, shaping clouds of dust into intriguing formations. In the Virgo constellation, a scorching gas giant named WASP-39b orbits its host star, a staggering 700 light-years away. This distant world, comparable in size to Saturn, dances perilously close to its Sun, its orbit 8 times nearer than Mercury's proximity to our own. Webb's mission to explore the farthest reaches of the cosmos has undeniably succeeded. Join us on Cosmic Discovery as we continue to unravel the mysteries of the universe in our next episode.